All right, fellas, so the last section in Chapter 16 here is Cramer's Rule. Cramer's Rule uses determinants to solve large systems of equations. All right, lots of variables, lots of equations. I'll show it to you with the two-variable case so you can understand where he came up with it. Okay, so if you look at this, through substitution, you should be able to know right away that x is equal to dE minus BF over AD minus BC. Okay? No, I'm just messing with you. You actually do get that result, but unless you memorized all the examples back from the hard problems in Chapter 3 last semester, you wouldn't know how that works. I'll show you how it works. Okay, so you got to isolate for one of these variables to try to solve the other one, just like you would if it had numbers. What happens is dy, right, on the bottom here, you subtract cx to both sides, and you'll have dy is equal to f minus cx. Okay, then you can divide by d to get y by itself, and so y is equal to this whole thing. Okay, f minus cx all over d. So you could take that and you could plug it in for the other y. All right, so we'll have ax plus b times f minus cx all over d equals e. Okay, now we need to solve for x here. That's what we're trying to do. So we have to distribute the b in. So we have ax plus bf minus bcx. This whole part is over d equals e. Well, that's a whole lot of stuff. We don't want to mess with that d in the denominator, so we can multiply the entire equation by d. Okay, so you have to distribute that everywhere to all three places, and we'll have a dx plus the d cancels out with this d, so we still just have bf minus bcx equals de. Okay? We're going to get all the x's together, get all the numbers to the other side. So we'll have a dx minus bcx equals de minus bf. Okay, you subtract the bf over. Then we have an x in both of these terms, so you could factor it out. Wait, that should be an ad, by the way. That should be an a. Okay. So pull the x out, we've got ad minus bc equals de minus bf. Okay, very last step, divide over the ad minus bc, and your result is x equals de minus bf all over ad minus bc. Okay, told you it was true. I know that's tough algebra, but I just want to show you how you get there. All right, now with that, you can do a lot of stuff. Okay, this is where he came up with this whole idea. Okay, let me get rid of some stuff here. Get rid of that. Okay, great. Now, we're assuming, because I just proved it to you, that's how you get x, and then you could substitute back in to get y. So let me show you what we have. We have x equals that whole thing, de minus bf over ad minus bc. And y equals af minus ce all over AD minus BC. Okay, so you could recheck your work or go through slowly when I was solving for the x. You could do it again for the y, and you'll get the same answer. Okay, so these will be the answers you come up with. Now, what do these look like in terms of determinants? Okay, well, if you look on the bottom here, they have the same thing on the bottom, AD minus BC. Well, remember we were making matrix equations. We made this matrix equation A, B, C, D times, right, xy, equals EF, right? When you do the matrix equation, that's what it looks like. Now, what's the determinant of this matrix? AD minus BC, okay? So this matrix right here, that thing at the bottom there, is we're going to call matrix D, okay? It's the determinant of the matrix ABCD. Okay, same for this one. ABCD. Now, if we convert the top into matrices or into determinants, okay, what actually happens here is you have, for the x one, you've got E, B, F, D. And for the y one, you'll have A, E, C, F. Now, what happened here? Okay, what happened? Well, all that happened here is for the x equation, you replaced the a and the c in the x column with e and f, okay, from over here. And for the y1, you replace the y column on top with, the y column with e and f, our constants again, okay? I know that's very tough to see right now. However, we're going to name these so it makes it a little bit easier to see. All right, we're going to name them dx is the top one. Okay, that's dx. And this one is dy. Okay, and the bottom one, the baseline, we're just going to call d. That's d, and that's d. All right, so determinant, determinant of x, determinant of y. Now, I wrote it out in words here so you can see it. So for the x, for dx, you're replacing the x column with constants e and f. Okay, you're replacing the x column with e and f from our ABCD matrix. For dy, you replace the y column with e and f. Everything else stays the same. Okay? Seems tough. I'll show you how it works. It's not too bad. Now, this is Cramer's rule. Okay? If you work these determinants out and do the division, you're going to get the x value and the y value. And this works for infinite number of, not infinite, but a large finite number of variables for our stuff. Okay? So Cramer's rule is the solution of a system of equations is x equals dx over d and y equals dy over d, z equals dz over d, etc., where d cannot be 0. Obviously, d cannot be 0. All right, so that's when most special cases. All right, the three variables case here, we're going to call them A1, B1, C1, A2, B2, C2, D2, all that stuff. Okay, so you can read. Our D for the three variable case is going to be A1, B1, C1, A2, A3, B2, B3. You see that? Okay. And what's going to happen is, so for dx, D1, D2, D3 is going to replace A. Okay. Just like that. Okay. Oops, sorry, that's dx. For dy, it's going to replace the second column. Right, so this is going to be where the d1, d2, d3 are. And these are going to be the c's still, and those are going to be the a's still. And dz is obviously going to take the third column. Okay. Now, how it works in the actual problems. Quickly. Okay, so solve each equation, each system using Cramer's rule. All right, so remember, in order to get x and y here, x equals dx over d, and y equals dy over d. So we need to find dx, dy, and d. So to start with d, to find d first, we need the determinant of all of our coefficients. 5, -4, 2, -3. All right, do the determinant of that, we'll get -15 plus 8 is -7. Okay, so d is -7. dx is the same as d, but you replace the x column with our constants. All right, so what you get there is 1, 6, -4, -3. Work it out, -3 plus 24 is 21. And dy here, you have to replace the y column with our constants. So 5, 2 stay the same, and 1, 6 go on the other side. You go 30 minus 2 is 28. So the way we solve these, just plug them into our equation. So for x, we've got 21 divided by -7, -3. And y, we've got 28 divided by -7, -4. And guys, it's that simple. That's the answer. X equals -3, y equals -4. Step a little bit more difficult to do a system with 3 unknowns. Okay, it's going to be harder determinants. Remember, we're going to have x equals dx over d, y equals dy over d, z equals dz over d. Okay, in order to get these, I'm going to make this go away. I can't erase. Oh, too many things. Guys, I'm struggling. Erase. Okay, I can't erase anything. All right, we'll just have to get more space. So to do d, we have a big 3 by 3 matrix. 1, 1, 1 across the top, 3, 0 because there's no y, -1, and 1, -1, 2. All right, dx, I'm going to set them all up and then we'll solve them. Dx equals, keep everything else the same, replace the x with our constants. Okay, these constants over here. All right, so dx is 5, 2, 0, 1, 0, -1 doesn't change, 1, -1, 2 doesn't change. dy, the same thing with the second column. 1, 3, 1 doesn't change, 1, -1, 2 doesn't change, but our 5, 2, 0 goes in the middle. And lastly, dz, oh, I don't have room for dz, I'll figure it out. Okay, let's start working. dz is 1, 3, 1 doesn't change, 1, 0, -1 doesn't change, and our 5, 2, 0 goes at the end. Okay? So, you guys can work out those determinants on your own, because I know you know how to do 3 by 3 matrices. I'll just show you the answers real quick. So, d is -11. dx, also -11. dy, -33. You see 33 there, yeah. And dz, finally, is -11. So, we plug them into all of our equations. Cool. I just moved that around. Okay, here's the answers. Okay, great. Okay, so we have, to find x, we need dx, which is -11 over d. -11 over -11 is 1. -33 over -11 is 3. -11 over -11 is 1. The answer is x is 1, y is 3, z is 1. All right, last two problems here. Get rid of that. Okay, last two problems here. All right, so these are just quick examples on what you need to do if your determinant comes out to 0, whether or not to know that if it's all solutions or no solutions. So the way this works, all right, we got to do the same thing. Our determinant, okay, here is 4, -8, -1, 2. Okay, when you work it out, you're going to get 8 minus 8 is 0. All right, now what you need to do here is figure out if these two equations are the same line or if they are parallel, right? The only two options, if they don't intersect, is either they're the exact same line, which is all solutions, or they're parallel, so there'll be no solutions. Okay, the way you check that is by checking dy. All right, so if you work out dy, which means you replace the y column with your answers, 4, -1, 9, 0, okay, you work this out and see what you get. We got 0 plus 9 is 9. All right, if dy is 0, then it's going to be no solutions. All right, they're going to be the exact same graph. If dy is not 0, anything besides 0, then that means that they're parallel, so it's no solution. So the answer to this one is no solution. These are parallel lines. If you graphed them, you'd get parallel lines. All right, this one over here, d equals 3, 15, 2, 10. All right, you work that out, you get 30 minus 30 is 0. dy, work that out. We've got 3, 2, 6, 4. What do we get here? 12 minus 12 equals 0. Because they're both 0, that tells you that they're the exact same line. So that means all solutions. That's it. Good luck, guys.